Good morning to all of you again. This is Rodolfo Eric Angat, your teacher in Earth and Environmental Science. Our essential question for today is, how are we protected from the electromagnetic radiation from the sun? This essential question covers the standard 1.1.3 and 1.1.4. In answering this essential question, we will be learning the vocabulary words radiation, radio waves, gamma rays, visible light, ultraviolet ray or UV, ozone, and magnetic field. So here on the TV, you see our essential question. The first thing that we need to know is that the sun is so special to us. Without the sun, we will not be here. We will not survive. The sun provides us all the energy that we need in order to sustain our lives. And at the same time, the sun also produces these types of radiation that can wipe out all the living creatures on Earth. But why are we still here? The sun releases solar flares, and these solar flares travel in space in the form of radiation. Radiation is a type of heat transfer that does not require a medium. So it does not need a solid, it does not need a liquid, it does not need a gas to travel. Radiation can travel in space. So sunlight can reach Earth even though that there is this space that is equivalent to 93 million miles of space. It can reach us because sunlight can travel in the form of radiation. Sunlight can travel in space because it is in the form of radiation or electromagnetic wave. Do you know how many minutes it takes sunlight to reach Earth? Yes. Very good. 8 minutes. So if the sun explodes, it will take 8 minutes before we know that it exploded. Okay? Because it's 93 million miles. So it will be a little bit late. Yeah, we won't be seeing it in real time because it takes 8 minutes for sunlight to reach Earth because of the distance. And this distance is also equivalent to 1 astronomical unit. Now, sunlight, just like what I said earlier, is the one that makes us survive on this planet. But it also presents a lot of danger. These are the types of electromagnetic radiation. From the longest, we call the radio wave, and we use this with our cell phones, TVs, and radio to communicate. Going to the smaller wavelength, the microwave, the infrared, the visible light, ultraviolet, X-ray, and gamma rays. Now, most of the radiation from the sun are either visible or ultraviolet radiation. Ultraviolet is not all bad. Ultraviolet, we have the ultraviolet A, we have the ultraviolet B, we have the ultraviolet C. They're not all bad. Ultraviolet allows our skin to produce vitamin D that allows our bones to become stronger. Okay? But the other types of ultraviolet radiation can also cause skin cancer and a lot of other diseases. Yes?
Does that mean if we have too much vitamin D, we can have skin cancer?
Not necessarily. Okay? Not necessarily. They are two different things. Now, if you have ultraviolet A, ultraviolet B, then they're not really that dangerous. But if you have the ultraviolet C, then that's the one that causes skin cancer. Now, visible light, on the other hand, is the spectrum that allows us to see each other. Without visible light, I will not be able to see you. And then we have the X-rays, and then we have the gamma rays. These two have the shortest wavelength, and that's the reason why they are the most dangerous. They are the most ionizing. When you say ionizing, radiation, these are the types of radiation that can cause damage to our DNA. These are the types of radiation that can cause mutation. And mutation on the DNA can be transferred to the next generation. That is why when you go to the dentist and they perform X-ray on your gums, you are given this apron that is so heavy. Remember that? Yeah, it stops radiation. It has lead inside that stops the radiation from going to the other parts of your body.
That's
Because,
why they leave the room?
say that again?
That's why they leave the room?
Yes, and that's another thing. That because the one who manipulates that device is a radiologist. So they leave the room so that they won't get too much of that radiation. Okay? Minimizing the amount of radiation that goes to your body is a way of maintaining your health. Okay? That's X-ray and gamma rays. Now, let's continue with this one. Now, astronauts, of course, they go to space. They are exposed to a lot of radiation. And that is why they have to wear these very thick suits to protect them from the different radiation from space. A student asked me, Mr. Angat, if there is no air in space, why do astronauts wear those very thick spacesuits? Why don't they just wear like the scuba suits, like the one that are used by those who dive into the ocean? The problem with space is not just the lack of air. It's also because of the immense harmful radiation that is present there. How come we are not so much affected by that radiation? It's because we have the inner core, which is represented by number 1, and we have the outer core represented by number 2. The rotation of the inner core and the swirling of the liquid iron in the outer core provides our planet with its magnetic field. It's like the force field of our planet. Earth's magnetic field is like a force field of our planet that deflects the radiation from the sun and from space. How does it work? You will see here the layers of Earth, and again, this is the inner core, which is solid, and then the outer core, which is liquid iron. Swirling liquid iron producing the Earth's magnetic field. And this is the swirling. Swirling iron in the outer core. Now, I need you to look at this one. Do you see this one? This is Earth's magnetic field. This is the sun's solar wind. Of course, the distance is not realistic, but I'm just trying to show you that the sun releases solar wind, and Earth's magnetic field protects us from that solar wind that contains a lot of radiation. Without Earth's magnetic field, the very first thing that will happen to Earth is that we will lose our atmosphere. And then, when we lose our atmosphere, we lose our water. But before we lose our water, we're already gone. We're already long dead. Okay? That's why our magnetic field is very important. Now, Earth is just like a bar magnet, which I will be showing you here. Okay? What you see here is a magnetic compass, and you will see that the magnetic compass is restless because I'm holding a magnet right here. I have to put it away. Okay? Now, the magnetic compass is always pointing to the north. So if that is your north, where is your east? Is it A or is it B? It's A. This is the east. That's why when you drive from Peters Creek going to Parkland, you will always see the sun right there. Have you noticed that in the morning? Then when you ride your buses going home, the sun is always right there at BB&T because that's west. Do you get that?
Yes.
The sun is always by the swimming pool, that is the east. This is the north. So this is the magnetic compass and it tells you that. See, this one is north, north, east, south, and west. The sun is always by the swimming pool of Parkland. Okay, ready? Now, let's show now why Earth is like a bar magnet. This is iron filings. Okay?
Plastic straw.
And then this here is the bar magnet. Now, let me put it on top. And then I will rotate it. Look what happens. Earth spins on its axis.
That's so cool.
Oh my God! Now, notice here that the directions of the iron filing are moving towards both poles. This is also what is happening on Earth's magnetic field. Here, on the North Pole, we see the aurora borealis, those colorful display of lights that you will see if you are in Alaska or if you are in the North Pole. On the south, you will see the aurora australis, also the colorful display of light in the south. This is Earth's magnetic field. It represents Earth's magnetic field. When sunlight hits Earth, the magnetic field of Earth protects Earth from that so much radiation that some of the radiation collects on this area and is displayed as colorful lights, and also in this area. Okay? So that is how it works with Earth's magnetic field. Now, let's continue with the benefits of the magnetic field. Okay. Now here, this one is Earth's magnetic field. These rays here are Van Allen belts, and they are the one that protects us from the different radiation from space, especially gamma rays and X-rays. Without them, then we will not be here. Again, just like what I told you, the first thing that will happen is that our atmosphere will be stripped away, and then the water will be stripped away. Of course, even before that happens, you're all dead. So we need our magnetic field.
I don't want to die.
Now, another protection that we have from the radiation from the sun is Earth's ozone layer. Ozone layer is found in the stratosphere, one of the layers of our atmosphere. The ozone layer protects us from ultraviolet radiation by absorbing this. That is why the temperature becomes a little bit warmer in the ozone layer, because it absorbs the ultraviolet radiation. Okay? So that's the ozone layer. Now, on your paper, you will see there the different types of ultraviolet radiation. You have UVA, you have UVB, and you should also have UVC, and you will see the differences between them. Okay? So that's it. Hopefully you understood the lesson about the importance of Earth's magnetic field and how it protects the atmosphere, the water, and most especially us, from the devastating effect of space and the sun's radiation. Thank you.